Alright guys, so today we're going to start getting down to the wire with some stuff. We are going to start what's called implicit differentiation, which is what I like. It's actually a lot of fun. It's like pieces to a puzzle. Sometimes we're not given functions that are nice, easily. Everything's given with x. We're given polynomials with y to the 4th times x squareds in there, and things that just aren't always simple. So now that we know how to use all of our rules applied to one variable, we're going to start throwing some more in there. Now, we're not going to crazy start doing calculus 3 stuff, which is fun. Using several variables. We're only going to talk about 2. Calculus 3 does this stuff using 4 and 5, and it's a grand old time, let me tell you. Just know that you will continue doing this in your math career. So implicit differentiation, just write down these steps for what we're going to do, and then we're going to put them into practice. So first you're going to differentiate both sides with respect to x. Means take the derivative of. Then you're going to collect all the terms involving dy dx on the left side. Then you're going to factor dy dx out. And then you're going to solve for dy dx. Now again, write this down. We'll talk about it here in a second. If you notice in this first example, we're given y cubed, y squared, y, and x squared. So we're going to take the derivative of this whole thing in respect to x. So what that's saying is, remember we've seen this before when talking about derivatives, we've seen it specifically when we've talked about our rules. Well, if I'm going to take the derivative of this thing, that means I'm going to shove it into everything. Or should I go this way? We're going to shove it into everything. When I shove it into everything, the derivative that we're focusing on is whatever letter is right here. Well, if that letter doesn't match up with the letter that I'm going to take the derivative of, we're going to throw on what's called dy dx. So the reason we call it dy is because we're only going to have x's and y's today. If we had a different variable, if we had t, it would be dt dx. If we had z, it would be dz dx. So when we take the derivative of a thing and it has extra letters in there, we're going to throw that letter up there on top with that first d. So it's taking the derivative with respect to x, and this is what's left over. It's the derivative of something we don't know yet. So we refer to it as dy dx. All right, keeping that in your head, let's go ahead and take the derivative of this. So the derivative of that first term, it's the regular power rule. So my 3 is going to come down. Y squared. Now, since that y is not my x, which is what I'm taking the derivative with respect to, which is what it's telling me, I'm going to throw on there that dy dx. So that's the first term. Let's take a look at the second one. Plus derivative of anything squared, bring down that 2, bring the y. Since it was not the same letter, we're going to go ahead and do dy dx. Now, this next one, I have the derivative of negative 5y, which gives me negative 5. But since I am taking the derivative of that y term, I need to throw on there that dy dx. Next, I got negative 2x. And the derivative of that constant in negative 4 is just 0. That's all it is. Just 0. So step 1. Take the derivative with respect to x. Cool. Step 2. Get all of the dy dx's on the left side and everything else on the right. So I have 3y squared dy dx plus 2y dy dx minus 5 dy dx is equal to 2x. So all I did essentially in that whole step between step 1 and step 2 is add over that 2x. That's the only term in this case without that dy. Okay, step 3. Factor out dy dx. So I'm going to take that dy dx term out, so I'm left with 3y squared plus 2y minus 5 is equal to 2x. Step 4, solve for dy dx. So I want to get this dy dx on one side. I'm going to keep it there in the left. So it's being multiplied with this whole big polynomial, so to undo multiplication, I'm just going to divide. So my final answer here is dy dx is equal to, I'm going to write the bottom first because the bottom is bigger and I want to make sure I have a big enough fraction. 2x over 3y squared plus 2y minus 5. So we don't know what the derivative of y is in this case, so because of it, that's why we have to set it equal to. Alright, let's try another one. Can I pull him apart? I cannot pull him apart. Okay, I cannot pull him apart, so what I'm going to do is I'm going to highlight all my work, and we're going to scooch you over a little bit. Hey, yay, room. So we're going to take the derivative of this whole big thing with respect to that x, because that's what we're putting on the bottom. So d over dx. So the derivative of this thing with respect to x is what that's saying. That first term is an x, so I'm used to that. So that's going to give me 2x plus. That next thing is a y, so we're going to take the derivative like we would. And then we're going to throw on that dy dx. And then the derivative of that 47 is just 0. So that's step 1. We derived with respect to x. Step 2. Get dy dx terms on the left side. Left side. Everything else on the right. So we're going to, in this case, subtract that 2x over. So I have 2y dy dx is equal to negative 2x. Okay, done. Step 3, factor out. Well, I don't really have anything else to factor out, so I can just move to step 4 for solving. This one's a nice easy one. I've only got that one term here. So dy dx is equal to negative 2x over 2y, which can reduce down to negative x over y. So yes, when possible, please reduce. This one over here wasn't really reducible, so I couldn't do it. This one I had 2 over 2, so that's how I can reduce down. Let's try another one. Oh, you are attached to. Ah, okay. I'm going to make my writing a little bit smaller. We're going to do thinner, so hopefully that makes it smaller. We'll try it. So we're going to take the derivative of this whole big thing. I'm scooting over so my hands don't jump too much when I do this. So we're going to take the derivative. So my first term's an x, so we're good. So I have 4x to the third. xy is x times y, which means we have product rule. So we got to think about this. So I have the first, so minus x. The derivative of that y would be 1 times dy dx. So I'm just going to say dy dx. Ah, that's not what I wanted. It's not what I wanted. So I essentially here have x dy dx. If I could keep it that thickness always. Oh, that'd be awesome. So first times the derivative of the second plus the second times the derivative of the first. So the second was y. Derivative of negative x is negative 1. That negative sign's still associated with it. So yes, it is -1. Plus, I've got another y term, so that 3 comes down. Y squared. Since he's not the same as the others, we have to do the dy dx. And that is equal to 0, because derivative of 6 is 0. Step 1, differentiate with respect to x. Step 2, get all the dy dx's on one side and everything else on the other. So I have -x dy dx plus 3y squared dy dx is equal to, this guy's moving and this guy's moving. So minus 4x cubed. That y is originally negative because it's y times -1, so it's going to be plus y. Okie dokie. Step 3. We factor out where we can factor. So I take that dy dx out of my -x plus 3y squared. Last step, we divide. So my dy dx is equal to -4x cubed plus y all over -x plus 3y squared. Again, I don't have anything that can factor out of any of this, so that is simply my answer. Okay, next one. We have lots of product rules. Yes, it's gonna be awesome. It's gonna be a great time. Okay, let's take the derivative of this guy. So first things first is I have a product right away. So I have the first term, which is x cubed, times the derivative of the second. So since it's just y, it's 1 times dy dx. So it's just dy dx. Plus the second times the derivative of the first. Whew, got one done. Goodbye. We got you done. You gone. Bye, Felicia. Okay, next one. Plus the first derivative of the second plus the second times the derivative of the first, which gives me 2y dy dx. And then equals that magical 0. If you haven't caught on, it's going to be equal to magical 0 basically the whole time. So before I go to the next step, I want to go ahead and simplify where I can, because that'll make my life a little easier because I've got some extra multiplication stuff. Ooh. So I have 3x, x cubed dy dx plus 3x squared y plus y squared plus 2xy dy dx is equal to 0. Now, whenever we deal with regular variables, remember x always goes before y, and the numbers always go in front, and yada yada yada. Okay, so we're going to keep everything that has that dy dx on the side, so this guy's staying and that guy's staying. So I have x cubed dy dx plus 2xy dy dx is equal to -3x squared y plus minus y squared. Sorry about that. I started adding plus and I was like, that's got to move too. So we're going to go ahead and divide out that dy dx. So I have x cubed plus 2xy is equal to negative 3x squared y minus y squared. So dy dx is equal to negative 3x squared y minus y squared all over x cubed plus 2xy. So the hardest part today is taking the derivative of a different letter. And that's all you're doing. And when you take the derivative of that different letter, you just tack on that dy dx. Oh, derivative of y, dy dx. Derivative of y, dy dx. Derivative of y squared, 2y dy dx. So all you're doing is regular derivatives with just a little thrown on top. Go ahead and do your homework.